This video is the second half of Chapter 6, and we're ready to discuss size of association, the degree to which the values of one variable vary, differ, or change according to those of the other. So I'm using the term size of association here, but this slide lists 5 terms, all of which have very, very similar meanings. So similar that in an introductory course, there's no point in going into the subtle distinctions, and indeed, I'm not sure that all would agree on exactly what those subtle distinctions might be. So the 5 terms with highly similar meanings are size of association, strength of association, size of relationship, strength of relationship, and finally effect size. But I mean, just to give you a feel for size of association, what we're trying to look at when we look at relationship is whether, as one variable changes in value, the other variable does as well. We're looking at, do certain values of one variable tend to go with certain values of another? Well, with size of association, now we're presuming that there is indeed association, which is to say relationship. We're looking at the degree to which the values go together. So one might have a small association. In other words, you can just barely see pattern, or on the other hand, in some situations, relationship is very large. Now, let me just give you a hypothetical example. So if almost everyone who smoked did indeed die from lung cancer, and if virtually no one who did not smoke did die from lung cancer, so we had a staggering difference in percentages, perhaps 90% of smokers, but only 10% of non-smokers dying from lung cancer, well then that's a very large or a very strong association. It has large size. But on the other hand, if we were to say that 23% in group A and 21% in group B experienced successful outcome, well, there is a difference. Those in A are more likely to experience the positive outcome, but obviously that difference is small. So intuitively, and indeed this is, correctly, that is an example of a very small association. So what we're going to try to do here is give you some tools to gauge size of association. And, as we go forward, do recall from the prior video that we're not concerned here with whether a relationship is or is not statistically significant. So we're just looking at size of association within our study sample. Question of, is this particular relationship perhaps or likely to be due to chance alone? That's the question of, is the relationship statistically significant? We're not discussing that issue until we get to Chapter 14, much farther along in the book. So let's look at some tools for assessing size of relationship between two categorical variables. The most common tool is the difference in percentages. This is a straightforward tool, or we could say measure, of size of association, and it's an informal measure. It does a particularly good job of helping one get a feel for size of association between categorical variables. And I think it's fair to say that many researchers look at differences in percentages and assess differences in percentages, in essence, by habit. Here you see a formula for the difference in percentages. One simply takes the percentage in a first group and subtracts that in a second group, and the difference is our difference in percentages. So we examined in the prior video a table in which 20% of new home adoptions versus 10% of foster family adoptions ended in disruption. Here's our calculation of the difference in percentages for that example. We simply subtract the percentage in the second group from that in the first. So here our difference in percentages computes to 20 minus 10, that is 10%. Well, here's a look at table 6.2, and we were doing our calculation of difference in percentages using the top row. There's our 20% minus 10%. One can calculate difference in percentages using either row of a 2x2 contingency table. Now let me just say, and I may have forgotten to say, that 2x2 table is referring here to the numbers respectively of rows and columns. So this contingency table, and we're only looking at the boxed area of the table, it has 2 rows. I mean, those rows are defined by the values of adoption outcome. So that's the first 2, and then you see it has 2 columns, those being defined by the values of type of adoption. So we have here a 2x2 table. And I should mention that difference in percentages is used predominantly in 2x2 tables. I'll show you later on how you can use it and adapt it to larger tables. But we did our recent calculation of difference in percentages using the top row, but one may use either row of the table. So let's go ahead and use the bottom row so that we could, for instance, take the 80% of new home adoptions and subtract the 90% stability figure for foster family adoptions, and we'd end up with minus 10%. Now that's a correct calculation of difference in percentages. I'm going to follow the guideline, and indeed sort of treat it almost as a recommendation, to subtract the smaller percentage from the larger. So if we're to use the bottom row, my recommendation is to subtract from 90% your 80%, and that yields the difference in percentages, of 10%. So the minus 10% is also a correct calculation, but I just do think that many people find negative differences to be counterintuitive. So the recommendation then is subtract the smaller percentage from the larger to calculate sort of the workhorse, everyday, even if informal, most common measure of size of association. Mostly this slide is just to look at. I mean, this is sort of summarizing some of the information that I was talking about as we were discussing the table. The recommendation is to make the group with the larger percentages the first group in the calculation. So in a 2x2 table, you can use either row calculate the difference in percentages. This text is always making the column variable the independent variable. And since the column variable is always the independent variable, the recommendation for the correct percentages to use in interpreting crosstab tables, and this recommendation applies to the difference in percentages as well, is indeed that you should use column percentages. So I mean the column percentages appear in the different rows. So in table 6.2, the percentages listed there were column percentages. They summed to 100 down the rows. So we were using column percentages to calculate the difference in percentages. And you can use the column percentages in either row. When you calculate difference in percentages, it is important to use the recommended percentages, those recommended in the guideline. So in this text, we are always going to use column percentages to calculate the difference in percentages. Now, those will be the only percentages that will be presented in any of the crosstab tables in this text. So you won't encounter confusion here, but it is indeed the case that in tables that you'll see on your own, they may present row percentages, and so you'll have to think about which percentages to use, perhaps. So here's another peek at table 6.2, and do observe again that these percentages are column percentages, which is to say they're summing to 100 down the column. For instance, 20 plus 80 equals 100. And I would just mention again, if you were to use the wrong percentages, so for instance, given that the independent variable would be the column percentages, as is the case here, if you used row percentages by mistake, you'll get a different value for the difference in percentages, and that value will be incorrect. So but in this course, you're just simply always going to use the percents that you see in the tables, and you'll compare those column percentages using either the top or the bottom row. This text presents qualitative descriptors of size of association for different measures of association. Now, I'm just going to start out and say that some texts do not present descriptors of size of association. The idea is that the author of that text would feel that, one thing they would feel is that what might be a large, medium, or small relationship in one substantive area might not be so in another. And they just simply think, I think, that the measures stand for themselves and that it's just not appropriate to put qualitative descriptors on. But I do indeed take the opposite perspective. I think qualitative descriptors help. It's sort of as simple as what shirt size do you take? Small, medium, large, or extra large. I think that having some kind of barometer or standard is helpful. Now let me say some things about the qualitative descriptors that you're going to encounter in this and subsequent chapters. Ultimately, these descriptors are non-mathematical. They represent informed judgment based on relationships that are often found in social science. So the gist of the matter is if you see a difference or relationship that is much larger than is typically found in social science, in essence, that relationship is going to be tagged or described as a large relationship. If you see a relationship that's much smaller or is smaller than many relationships that are often found in social science, and some of the notion would be it might be so small that it would hardly be worth considering at all, well then that's going to get a designation as a small relationship. And these qualitative descriptors are approximate. They're to help you get a feel for a relationship. So don't just slap labels on. Use these descriptors as a starting point to think about how large or small the association in your sample is. These descriptors are providing a rough guide to size of association. And indeed, there is certainly some credence to the notion that what's large in one substantive area may not be so in another. So these are to help you get a feel for the associations and differences that you'll see in research. So here are our qualitative descriptors for the difference in percentages. So differences in percentages of about 7%. or about -7%, are considered to be indicative of relationships that are small in size. And, size of association and strength of association are in essence synonyms. So if you choose to speak in terms of strength of association, and some researchers do, others tend to speak more in terms of size of association. And just to slip this in, one could all just as well say size of relationship or strength of relationship, because association and relationship are just simply used interchangeably. But if you choose to describe in terms of size of association, you have descriptors of size, whereas for strength of association, our descriptors convey strength. So a difference of about 7 percentage points is a small association, or we could say a weak association, and I'm meaning approximately so. And on the the other end of the continuum, were you to see a difference in percentages that was about 45% or greater than this, or I could also say a difference in percentages that was less than -45%. Now we're dealing with size of association that is clearly very large, or we could equally well say that the strength of association is very strong. So, in table 6.2, we calculated a difference in percentages of 10%, and so these qualitative descriptors are in the context of social science and social work research, but the 10% is fairly close to this 7% guideline for small or weak association. So basically the relationship that we see between adoption type and adoption outcome in table 6.2 is a fairly small, or we could say a fairly weak relationship. Note at the bottom of this table of qualitative descriptors that when any compared percentage in the contingency table is less than 10% or greater than 90%, the descriptors in this table should not be used. I did mention that the qualitative descriptors certainly should not be used for difference in percentages when you have some percentages that are less than 10% or others that are greater than 90%. And I'll just go out on a limb a little bit and say that when you have percentages in your contingency table that are less than about 10% or greater than about 90%, difference in percentages probably isn't too good of a measure to use. So, if you had 3% in one group and 6% in another group experiencing unsuccessful outcome in some endeavor, well then 3% and 6%, both of these are less than 10%, and that's an example of a situation where, in general, the difference in percentages isn't a preferred measure. Let's try to give you some kind of a feel for why the qualitative descriptors don't work well. And I'm going to say in particular when percentages are close to 0, which is to say less than 10%. So suppose that 8% who take vaccine A and 1% who take vaccine B develop serious illness X. Let's calculate the difference in percentages, and it calculates to 8 minus 1, 7%. So then the question comes, is the relationship between vaccine and illness weak, which is to say the same as small, as the qualitative descriptors would indicate? Recall that differences of about 7% are small or weak in terms of how they're characterized. And the answer is no. The relationship here is not a weak relationship. And it's not a weak relationship, and I'm working intuitively here, but it's not a weak relationship because those who take vaccine A are 8 times more likely to become ill. And hopefully it's intuitive to you that 8 times more likely is a big difference. It's not a small relationship. So when you have percentages that are not in the range between 10 and 90, particularly when you have percentages that are close to 0, the risk ratio is preferred to the difference in percentages. Well, here is the risk ratio. To calculate, we're going to divide the percentage in group 1, experiences an event, by that in group 2. For the vaccine example, and we've got to designate one group as the first group. Let's make the vaccine A group the first group. So the percentage becoming ill in the vaccine A group was 8, and we're dividing by the percentage in group 2, the vaccine B group. 8% divided by 1% yields our risk ratio, which in this case is 8. Basically, quickly, this risk ratio is communicating to us that those in group 1 are 8 times more likely than those in group 2 to experience the illness. So with these percentages, both below 10%, I mean, the risk ratio is a good measure here, better than the difference in percentages. Let's go ahead and see what would have happened had we designated vaccine B as group 1. Well, here is our risk ratio. The risk ratio calculates to 1/8, or we could say to 0.125. And here's just a little point that would be worth remembering, and that is that changing the group designated as group 1 makes the risk ratio calculate to a reciprocal. So, I mean, reciprocals multiply together to 1. So when we switched from group 1 to group 2, we switched from risk ratio of 8 to risk ratio of 1/8, and you can see that these are indeed reciprocal risk ratios because their multiplication yields 1. Reciprocal risk ratios convey the same size of relationship. And ultimately, it's arbitrary which group you designate as group 1 and which as group 2. Now, here's a hint or a recommendation, a guideline. When it's convenient to do so, designate the group with the larger percentage as group 1. I mean, make group 1 the numerator. And if you do so, your risk ratios will calculate to be greater than 1. And most people find it a little bit easier to interpret risk ratios that are greater than 1 than to interpret those that are less than 1. I mean, it's not a huge difference, but I think many people think that this group is 8 times more likely to experience the result. Well, that's perhaps clearer than to say this group is only 1/8 as likely. But I like to follow this convention. I mean, particularly the risk ratio of 8 is more straightforward than is the risk ratio of 1.25 in terms of ease of interpretation. A couple more points to mention on the risk ratio. One is to say that a risk ratio of 1 is conveying the absence of relationship. You know, for instance, if, say, 6% in group 1 and 6% in group 2 develop the illness, then our risk ratio would be 6% divided by 6% and would be 1. So that risk ratio of 1 is going to get that risk ratio when percentages are equal. And then as the risk ratio diverges from 1, size of association is getting larger. So I mean, it gets larger as it moves farther away from 1 towards 0. I mean, there's no such thing as a negative risk ratio. But for instance, a risk ratio of 0.20 conveys stronger relationship than does a risk ratio of 0.50 because it's farther away from 1. I mean, it's more intuitive that risk ratio is conveying increasingly larger size of association as you move away from 1 in the positive direction. So it's, for instance, a risk ratio of 5 conveys stronger association between 2 variables than does a risk ratio of 2. So here are some guidelines for risk ratio, and you can see again that as these are moving away from 1, the relationships are getting stronger. So a risk ratio of about 1.5, or its reciprocal, 0.67, that's conveying relationship that's small in size, and if you get a risk ratio of about 10, well, clearly that's conveying a very large association between 2 variables. So a risk ratio in our example was 8, and so that's in between the guidelines for large, which would be 4, and very large, which would be 10. And these qualitative descriptors are, they're approximators. They're just rough guides. So let's just say to ourselves that this relationship that we're seeing between vaccine and illness is quite a large one. It's large to very large in size. I want to make one more point about risk ratio. And risk ratio is a good tool when you're finding percentages that are close to 0 or close to 100%, as in our example. You can use it in other situations, but I think it's really optimal when percentages are close to 0 or to 1. Do be sure to use the percentages in your calculation that are close to 0 rather than those that are close to 1. So that, for instance, if 8% develop the illness with vaccine A, then you know that 92% do not. I mean, 100% minus 8% tells you 92% do not. And similarly, for vaccine B, 99% did not develop the illness. So you could, and it's not incorrect, you could compute your risk ratio using these percentages. And here it is. And it comes to 1.08. And the idea is this risk ratio is correct mathematically. It doesn't have straightforward intuitive interpretation. And clearly you can't use the qualitative descriptors with this risk ratio. So choose the percentages that are closer to 0. A final note, and we'll get into this in the next chapter, is that sometimes you have sort of a mixed bag of percentages. You might have 6% in one group versus 50, which is say 50% in another group. I don't recommend using risk ratio when one or both percentages is greater than about 30. And let me rephrase. It is okay to use risk ratio in a situation like that. It's not the optimal measure. We're going to go on to the next chapter and see a better measure. I mean, the more central point is that the descriptors, the qualitative descriptors, not be used when one or both percentages that are being compared is greater than about 30%. So that concludes Chapter 6. Chapter 7 begins with the odds ratio, which is a really good measure for 2 by 2 tables.